Welcome to our session today. I am Daniel Stuckey, the Cisco Program Lead here at Madison Technologies. We're joined today here by Amit Raj and Ash Khan, and we welcome you to today's session. Some housekeeping for today's presentation. For the best experience, we have muted microphones for the duration of the presentation. If you have any questions, please feel free to post them in the Q&A panel, which is supported today by Cisco and the Madison Technologies engineering team. So without further ado, I'll hand you over to Amit.
Hi everyone, my name is Amit. I'm a Solutions Engineer at Madison Technologies, and today we are going to talk about Cisco IoT in transportation. So the purpose of this presentation is to provide a connected mass transit solution to improve efficiency, safety, security, and passenger experience. A mass transit system is a network of transportation services designed to move people within a city. Now, the common example of mass transit system is buses, trams, trains, light rail system. Today, we'll focus on the buses connecting to a cloud-based solution that can seamlessly integrate with smart cities of tomorrow. So the goal is to talk about connecting the bus fleet to Cisco Cloud for business application, fleet management, and operations center management. Okay, so let's take a closer look at the mass transit reference architecture. So this is a mass transit reference architecture. This architecture is broken down into multiple zones, and these zones reflect major functions relevant to the transport operators. So first zone is connected vehicles and fleet. This zone is all about the buses or vehicles we use for transportation. It includes the hardware and software components installed on the buses to make them connected. These components might include GPS tracking devices, telematics systems, communication modules, and sensors. So the goal is to ensure that vehicles are equipped to provide real-time data about their location, performance, and their relevant metrics. Now, the second zone is depot and operations center. This zone focuses on physical infrastructure, where the buses are stations when not in service. It includes the bus depot and the operations center, which is responsible for managing the transit fleet. Here, tasks such as maintenance, refueling, charging, and scheduling are coordinated. Next zone is data center and cloud. Now, this zone acts as the central hub for data processing, analysis, and storage. It connects the transit system to data center and cloud infrastructure, where data from connected vehicles and operations center is aggregated, processed, and analyzed. Now, this is a simpler depiction of the proposed solution. In this slide, you can see that the bus network is connected to the cloud for business, fleet, and vehicle management. Such a solution can lead to improved efficiency, safety, and passenger experience in the mass transit system. So how do we do that? We use something called the Industrial Router 1800 or IR 1800 for short. This is a ruggedized industrial router designed to revolutionize the way we manage moving assets. Let's dive deeper into the IR 1800. So this is a modular industrial router which offers connectivity with modules for storage, Wi-Fi, and LTE. Its features include GPS tracking, ignition power management, and all these features make it tailor-made for managing moving assets. It has built-in security and cyber vision sensor for visibility. It is purpose-built for moving assets. So why do I say that? Because for moving assets, there are few things to consider. Because it moves, you probably need location. So it has a GPS or GNS module. IR 1835 uses the measurements from GNS receiver, gyroscope, and accelerometer to provide you the accurate location of the assets. Because it moves, it cannot be rack mounted or DIN rail mounted. So the router is flat and is designed to be installed either behind or under the seat of the bus. It has ignition power management. Now, ignition power management ensures that the router automatically powers on when the ignition is turned on and powers off when the ignition is turned off. So it can also be configured to remain powered on for a set period of time after ignition is off. Okay. CAN bus communication. It is a serial bus communication standard which is used in vehicles due to its reliability. It also has edge compute technology, which is IOX. So IOX is the operating system that gives us the ability to run Docker-based application to transform the real-time data for processing. Now, there are 4 models in Catalyst IR 1800's ruggedized series router. First is IR 1821 and IR 1831. Now, IR 1821 and 31 are the entry level and mid-range models, where IR 33 and 35 are the high-end and industrial models. The features are, the higher you go, the more modules you can install on the router. Now that we understand the IR 1800's capability, let's revisit why it's crucial for our mass transit solution. So, in the world of moving assets, when things are moving, their requirements become unique and different. I've listed a few of them here. So, does this asset move in public space or private space? Some applications require very little bandwidth. Some require a lot of bandwidth. So does it need a lot of internet speed or just a little? Then there's a notion of failover. Is it crucial to keep the network up at all time? Or if we have to, how do we failover or provide the redundancy? And is it a good financial investment or is it too expensive? There's security. In today's world, security is our top priority. So we need to understand if this measure can provide us the robust security. Now that we understand the challenges of managing a moving asset, let's explore how we connect these assets to the internet, private data center, and cloud within our topology. Connecting assets to the internet, private data center, and cloud has 3 options. So first option is to provide public cellular network with a VPN tunnel. So you still use the public internet, but on top of that, you have an overlay network with tunnels. It provides private connection over public internet. Getting VPN tunnel will provide you the security. It'll provide you the ability to route packets to your private network. It will also provide you the ability to isolate the private traffic from the public traffic. Another option is to use public network with private APN. Now that is going to be using public cellular network but with a private APN. Now your phone has a database of all the APNs. So when you plug a SIM into your phone knows which network to connect to. It is based on the APN on the SIM card. So it knows whether to connect to Telstra or Vodafone. Now, this APN is a reference point or address for your device to get access to the internet. So when you use private APN, this SIM card connects directly to your data center. So you don't need a VPN tunnel here. If you have to go to the internet, it has to go to the data center and then you can access the internet. And the third option is establishing a private cellular network. Now, in this scenario, you essentially become your own cellular operator. But this is a complex solution involving spectrum allocation, infrastructure deployment, and radio setup. So you have full control, but you must invest in the infrastructure and spectrum management. The only problem is cost. So to leverage the cellular option on IR 1800, we use IR 1800 PIM module and the SIM card for multiple providers. Now we have IR 1800 and this module that you see on the screen is called a PIM module. For Australia, we have PLTE LA for Cat6 and 5G modules for 5G module is universal. It is P5G S6GL. So you can have either 1 or 2 PIM module for cellular and each module has 2 SIMs but 1 radio, SIM 0 and SIM 1. They both use 1 radio. So we can have 1 SIM from one provider and another SIM from another provider, and when one doesn't work, we switch to the second operator. So when you do this, you have 2 SIMs, two different operators. First one doesn't work, we switch to the other one, and that provides some level of redundancy. Next up is security. So IR 1800 comes with the inbuilt security and Cisco CyberVision sensor. CyberVision is a deep packet inspection that uses network as a sensor. CyberVision transforms the router or a switch into a sensor, and it inspects the industrial traffic to find weaknesses in the industrial devices and protocols. Essentially, it reports to a central server to tell that this is what I've seen and these are the risks in the network, and this behavior seems suspicious. So Cisco emphasizes a systematic approach to secure infrastructure through solutions like Cisco CyberVision and ICE. How do we do that? First step is to define IT and OT boundaries with Cisco Firewall. Once that is done, use CyberVision sensor to find out what needs to be protected, and then segment the network into logical zones and put policies using ICE to control the traffic. And finally, develop a team or person who will be responsible for investigation in case of any incident. In summary, we connected the bus network to cloud that enhances efficiency, safety, and passenger experience. The IR 1800 router plays an important role in securing connectivity, redundancy, and overall security of the bus network. Thank you very much for joining us on this journey through the Cisco IoT in transportation. We invite you to join us for the Q&A session where our experts will provide you the insights and answer to your questions. Please don't hesitate to reach out to me using the contact details you see on the screen. I hope this session was informative to you. Thank you very much, and I'll hand it back to Daniel now.
Thanks, Amit. In today's session, we reviewed the challenges we see in transportation. Cisco's IoT solutions in transport aim to improve mass transit systems by leveraging connected vehicles and cloud-based architecture. These solutions address the challenges of mobility, bandwidth, failover, cost, and security, ultimately enhancing transport efficiency and passenger experience. To learn more on how Cisco and Madison Technologies can assist you, feel free to contact your account manager or myself using the provided contact details you see. Finally, we would like to request your support. To enhance the contents of these webinars, we rely on your feedback to guarantee we are providing the most relevant content. Kindly review the post-survey link we will be sending you and share your valuable insights with us, or simply scan the QR code you see on the screen now. Thank you for participating in this webinar, and we look forward to speaking to you soon.